kind of look like a mountain. In Algebra 2. So if I'm looking at histograms, let's just talk about, let's go with maybe the females first this time. If I do a histogram for the females, and again, I could go with the split. So if I went with the split, you want to make sure that on the horizontal axis, you do a double bar to indicate that you're not starting at 0 and going all the way up, so you can start wherever you want to. And then I can put, like, for example, 150, 155, 160, 165, 170. And that way I can display my data in a condensed form, and I don't have to go from 0 to 150. So the double line indicates that there's a split in the horizontal axis. And then as I go up the sides, you can go by singles: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as long as you can indicate the scale, you're going to be in good shape. And because I run out of room, I'm just going to leave it like that. So if I look at the female heights between 150 and prior to 155, which is the next set, you will notice that in the orange on the left, there were 3 females that fit into that category: 152, 153, and 153. So as I draw my histogram, I'm going to draw a bin that is 3 units high for the histogram. So there are 3 females between 150 and 154. The left side of the bin indicates the first value in that bin. So in the next bin that I draw, the first height that could be in there would be a 155. So I look on the next line, I don't have a 155, but from 155 to 159, there are 5 values there. So I'm going to draw a bin that is 5 units high. And this orange bin is indicating the heights of 157, 158, 158, 158, and 159. And then in the next bin, from 160 to 164, there are 6 values. And again, if you want to make sure for the reader, you could put the number 6 on the top. Oftentimes, these numbers are very helpful for you when you're figuring things out, when they ask questions about your histogram, because they will ask you questions on the AP exam about histograms, how many values fall in this bin or whatever. So that's kind of helpful. And then in my last bin, from 165 to 169, there are 7 values, according to what I have up on the board. And this is what your female histogram would look like. And again, remember, you should label the horizontal axis, so this would be down across the bottom, this would be height in centimeters. For the label across the horizontal axis, the title would be female heights. And then across the left, or the vertical axis, I would put down the number of females as my label. So what happens is, after you enter in all of the data, Aaron, in list number 1, you're going to go to your stat plots. That is second y equals. This is how you do a histogram. You hit enter, and you hit enter again to turn on your plots. Then you arrow down, and you want to go to the histogram graph, which is the one that's, I call it the third one, and hit enter. And it'll say, which list do you want to work with? And generally, I put my stuff in list 1. That's the X list. And you want the frequency to be 1. And for the window, you want to choose a window. Sorry, I'm in the wrong mode from Algebra 2. Give me a moment. You want to choose a window that makes sense. For example, my histogram smallest value for the females is not lower than 150, right? So I'm going to choose 140. And the highest height for the females doesn't go above 170, so I'm going to pick 170 as the highest. You need to pick something that makes sense, maybe one bin width on either end of what the bins that will be showing up would be. Each bin is going to be 5 units wide. And you really don't need to be in the negative numbers. You just need a horizontal scale. So I can start with 0 for the y values. And there aren't probably going to be more than 10 values in each bin. And that's the height of those bins, the y maximum. And then if I go to graph, I should see my bins. Now it looks like I went all the way to the right and I have an extra bin on the left, so I could go 5 less on the left if I wanted to. But I like to see a window that actually has space on the right-hand side, so I would actually choose, instead of going to 170, I might choose 180, because I like to see space on either side when I graph these to get an idea. So here's my set of bins for the histogram, and if you look back at what our histogram looked like for the females, you can kind of see that's what it looked like for the females. There were 4 bins successively higher. And the kind of the cool thing about your calculator is if you go to your calculator and you hit trace, it'll tell you in each bin where you are. So if I arrow to the right, I can see that at the top of the bin, the n is 3. It tells me that there were 3 values in that bin. It tells me that there were 5 in the next, 6 in the next, 7 in the next. So the nice thing about your calculator is it can tell you how many values are in each bin once you put the histogram in. All right, we're going to skip the male one since I think you're good with the histograms after that. In this next slide, there's a lot of information about interpreting our data. So the phrase that we use in statistics that helps us remember the things we need to talk about when we talk about the data is SOX. That stands for the shape, outliers, center, and spread. And we'll talk about each one of those. So when you're talking about the shape of a graph, you want to know about the overall pattern. Is it symmetric? So the left and the right sides are about the mirror images of each other. Could it be skewed to the right? So skewed to the right means it extends much further. If I were drawing pictures of these things, a symmetric distribution would look something like this. A skewed right graph would look something like this, where the tail goes out to the right. Skewed left means that the tail goes to the left and the hump is to the right. Unimodal means there's one peak. Bimodal, so unimodal is kind of like the one that we did originally, way up here. Bimodal would be something where there are 2 peaks. So you'd see something like this for bimodal. And then multimodal means there's many peaks. And so you might see something like a spike in the graph, and then maybe another one, and then another spike in the graph, so on and so forth. Okay, so center, you probably talked about a lot in some of your past classes. It's a value that divides the observations so that half are larger and half are smaller. And so 2 of those main ways that we talk about it are the mean, which is the average, and then there's also the median, which is the exact middle. So mean and median. And the normal way to talk about the mean is with this thing we call x bar. And you might not recall what some of these symbols mean. So the capital E looking thing is called sigma. And it means the word sum, or in other words, add all these things up. The x sub I thing that you see over here is just talking about each individual data point. Individual data points. And then n is talking about the number of data points or data points. So you add up all of the data points and divide by how many there are, and that's your mean. And the median is one exactly in the center. Okay, so the median is not always as easy as it seems. The steps to find the median: number 1, arrange all your observations in order from smallest to biggest, or in other words, in ascending order. If your number of items is odd, it's the one that's exactly in the middle. If it's even, you take the 2 middle things and average them. So I want you guys to try and find the median of the following 2 lists. Okay, so in list number 1, we have 13 items. That means there's an odd number of things. In order to find the one that you want, you take that number 13, add 1 onto it, chop it in half, and I want the 7th item, so I just count over to the 7th item. 1, 2, 3, 4, 5, 6, 7. And so the one that I want, which is the 7th item, is this one. And that means that my median is 7. In the second list, I have 16 items. So that means I need to look at the middle two things. And so as I look at the middle two things, that means since I have 16, that means number 8 and number 9 item. So as I look at number 8 and number 9 item, 1, 2, 3, 4, 5, 6, 7, 8. These are my two middle items. And I will average those two things. So 4 plus 5 divided by 2 is 4.5. Now kind of the strange thing to me at least is that when you're talking about median, sometimes the median doesn't even exist as an actual value. Sometimes it does and sometimes it doesn't. So your median doesn't have to be a value in the list. It's always whatever's in the exact middle of the list, whether it exists or not as a data point. Okay, in this next slide, we're going to talk about some other measures. Spread is the variability of your data, talking about the lowest and the highest values. So basically, all you got to do with the spread is take the big minus the small. That's for the spread. Now, I shouldn't say big too small. That'll make it easier to say. So for example, if I had a list of numbers, I would say the spread is from something to something, which seems kind of redundant when you talk about the range, which is actually where you subtract big minus small, and you get some kind of number. So the range is a number, and the spread is a sentence. Back in the day, before the advent of our nice graphing calculators that we had, we'd have to actually calculate standard deviation by hand. It was kind of a pain. This is the formula that they use. You're not really going to have to do that because our calculator does that for us. Okay, but just so you know, if your batteries go dead, this is how you do it. So your standard deviation will be 1 over the number of items minus 1 times the sum of every item minus the mean, and then squared square root. Kind of a pain to do by hand. When I was in my master's program at the University of Minnesota, they made us do it by hand. It was great. Variance, all you got to do is square the standard deviation. So you just square it, and you get your variance. So what we're going to do is we're going to find all these things for the following list. So I'm going to pause now, put this in my calculator, and then I'll show you how to do this